All right, so this is adding, subtracting, multiplying complex numbers. I'm going to define the complex number. We've talked about imaginaries and we've talked about real numbers. Complex numbers is a mixture of a real number, and I'll actually give you examples, and imaginary put together. So real numbers and imaginary numbers. So it'd be like a real number is like 3, and then plus, they'd be joined with a plus or minus, plus 6i. So we have a real number and you have an imaginary number. So you can be 4 minus 3i. Just, you can join with additions or subtractions. So you have, again, the real number joined together with an imaginary number, and that is called a complex number. So let's dive into adding, subtracting. Well, first we'll start with adding and subtracting. You're really going to treat these numbers, each term, as if it's like a variable. You're going to join your like terms together. It's very similar to if it was like 2x or 3x. 2i and 3i, treat them the same way when it comes to adding and subtracting. So we have, look for your common terms. So we have 6 plus 5. Well, that's your real number. We start off with the real numbers first. And then we're going to go with, and you always look at the operation before the term. So it's a positive 2i minus 3i. 2 i's minus 3 i's. That means you're going to have a negative 1i. Or negative 1i, or you can even simplify this down to 11 minus 1 times I is I. So 11 minus I. That would be your final answer there. On the next problem, we have the parentheses first. So looking at the parentheses here, we have to get rid of the parentheses. So why are the parentheses here? You have to first realize that. And it's because you're subtracting everything in the parentheses. So the first thing I would do is I actually distribute this negative. And you really could think of it as like a negative 1 here, if that helps you. It's a negative 1, and we're going to distribute it. So I'm going to first write down everything so we have 3 plus 7i, and then we're going to distribute the negative 1 times negative 8 is a positive 8. Negative 1 times 2i is a negative 2i. So it's just negative 1 times 2 is negative 2, and there's an I there with it. So now the parentheses, we can drop them because we distributed that subtraction to both terms inside of it. Now we're going to look, just like in example 1, what our like terms are. So looking at our like terms, we have 3 plus 8. So again, that's 11, just like the last one. It doesn't always add up to 11, just a coincidence. And we have positive 7i minus 2i. So 7i minus 2i, 7 minus 2 is 5. So that's going to be 5. So plus, the 5 is positive, so plus 5i. There's your final answer. All right, next example. So that was adding and subtracting. The next one is multiplication. There's multiplication in between here. In between both binomials, each in parentheses has the 2 terms, so they're known as binomials. There's multiple ways you can do this. I'll show you 2 ways to multiply this out. The first way is, some of you know it as FOIL. So you have first multiply the first 2 numbers together. So you are distributing, it's called double distribution too. You're distributing, multiplying every term times every term. So negative 8 times 6 is negative 48. Then let's do this in different colors. Negative 8 times 4i is negative 32i. The great thing about all these colors, we can do this. So negative 7i, we can distribute that, or positive 7i, it's a positive 7i, times 6 is a positive 42i. And 7i times positive 4i is positive 28. So it's I times I is I squared. All right, now we need to look at, are there like terms? So now all the parentheses are gone, so let's look, see if we can gather like terms, and we certainly can. We have 32, or negative 32i plus 42i, so we can simplify that. So let's go to the next step here. We have negative 48 first, and then negative 32i plus 42i, that is 10i. And then what can we do in this last part here? The positive 28i. That one, you have I squared. We have I squared. I squared is equivalent to negative 1. So always remember that I squared equals negative 1. So we have, this really means 28 times I squared, so it's really going to be 28 times negative 1. So that's going to become negative or minus 28. Well, that's pretty cool because the I squared goes away, and now we actually have like terms again. We have negative 48 minus 28. And I think I ran out of room here, so, or maybe I can squeeze it in. Negative 48 minus 28 is negative 76. And then plus 10i. And there's your final answer. So working out that problem in a different way, you can do the Punnett square. So if I'm going to do this in a different way. So if you know how to, if that worked how I just showed you there, you can fast forward to the next example. Otherwise, keep with me, and we'll do this. I'll do this with the Punnett square. So Punnett square, 2 terms times 2 terms. So I'm going to do a 2 by 2 square. So you have negative 8 plus 7i and 6 and a positive 4i because it's a plus. And what you're doing is you're multiplying each box out from what's in the rows or columns. So I'm going to start with negative 8 times 6 is negative 48. And then 7i times 6 is 42i. And then 4i times negative 8 is negative 32i. And 4i times 7i is 28i squared. So now the cool thing about the Punnett square, pretty awesome. You always have like terms. They should be diagonal of each other, but you always look for like terms. There those are. And we can also, you can simplify this right away if you'd like. So it's simplifying the 28i squared. Remember, I squared is negative 1, so 28 times negative 1 is negative 28. So that's going to be a negative 28 in there. And now we actually have like terms here also. So negative 28 minus 48 is negative 76. And negative 32i plus 42i, because it's positive, or 42i minus 32i. Doesn't matter which way you do it. But that's going to be a 10i. You can do it either way. Doesn't matter to me. Either way works. All right, simplifying. Now, it's very similar to example 3, except I want to make sure you see a binomial squared. Binomial squared, what is this square? What does that mean? What does that square mean? Well, square means whatever the base of that is, the base of this square, the parentheses means it's all of this, the 6 minus, that's the base. That means it's multiplied twice. That's what a square means, multiplied by itself. If it was a cube, we'd multiply it 3 times. So here, multiplied by itself. Now it's going to be exactly like example 3. So if we're going to do this with a Punnett square, we certainly can. So 6, it's a minus 4i. 6 minus 4i, doesn't matter which one you put where. 6 times 6 is 36. 6 times negative 4i is a negative 24i. Negative 4i times 6 is negative 24i. Negative 4i times a negative 4i is a positive. 2 negatives multiplied by positive, 16i squared. Look, to simplify things, we have an I squared here, so that's -1. So this is really 16 times -1, which is a -16. And then we have like terms, -16 and 36. Add those together, that's, or 36 minus 16, doesn't matter if you actually add them or not. So it's, or you could do -16 plus 36 or 36 minus 16 is what I'm trying to get at. That's 20. And then we also have -24i minus 24i. And that's, or you could do plus a negative, minus 48i. You're just counting how many i's you have, and then there you go. That's your complex number. All right, come to class with any questions.